The other mechanism for substitution reactions is the SN2 mechanism. Again, substitution reactions overall will look like this, where we have RLG plus a nucleophile, and we'll get R nuc plus LG. So this is called the substrate, the part of the molecule that has the ability to leave the original molecule and be stable as often an anion, but sometimes as a neutral molecule, is called the leaving group. Usually the atom right beside the carbon here will be an electronegative atom, and so it will give a partial positive charge to the substrate and a partial negative charge to the leaving group. The nucleophile can be neutral or negatively charged, but it will have a partial negative charge at least. So partial negative or full negative charge. Then this will be the product, and then this will be the leaving group. And again, often the leaving group will have a negative charge or sometimes a partial negative charge. So the SN2 reaction stands for bimolecular nucleophilic substitution. So that means that there are two molecules involved in the rate determining step. And the two molecules are the substrate and the nucleophile. So it turns out that that means that this will be a single step mechanism. Whereas with SN1, which is unimolecular, you only have the substrate. The leaving group leaves. That's the first step in the rate determining step that gives you that carbocation intermediate. And then the nucleophile will attack that carbocation. Here, all of this is happening simultaneously. So we're going to have two arrows in our single step. And in a lot of ways, they mimic the arrows of the proton transfer reaction. So this is going to look like this. So RLG. Again, we have the partial negative here and the partial positive, which makes that carbon attached to the leaving group an electrophile. So the nucleophile is going to come in and attack. Usually with an SN2 mechanism, that nucleophile is going to be negatively charged, but not always. And the leaving group is going to leave, and all of that is going to happen simultaneously. So we end up with the R nuc plus the LG. And in this case, it would be a negatively charged leaving group in most of these situations. So the nucleophile bonds to the electrophile and the leaving group leaves. All of that happens simultaneously, and that is the SN2 mechanism. And looking at the kinetics for this, since this is the only step and it involves both the nucleophile and the substrate, the rate law will be K times substrate concentration times nucleophile concentration. So that means for this reaction, doubling the nucleophile concentration would double the rate. Doubling the substrate concentration would double the rate. Having the nucleophile concentration would half the rate. So one of the ways we can test to see is this reaction SN1 or SN2 is to do a kinetic study and determine the rate law. So if we have kinetic information about the reaction that can help us determine, is it SN2 or is it SN1? Now, with all these reactions we're talking about right now, the SN1, SN2, E1, and E2, these can be in competition with each other, and more than one of them can be happening simultaneously. Remember, in a reaction mixture, you have millions of molecules all running into each other, and so some of them could go via one mechanism and some of them could go via a different mechanism. In the next video, I'll talk about the stereochemistry of this reaction. One last thing I want to add about this mechanism is, unlike the SN1, which can sometimes have a proton transfer before, a carbocation rearrangement in the middle, and a proton transfer at the end, the SN2 really tends to just be the SN2 step and nothing else. Because usually the nucleophile is already negatively charged. It can't rearrange because it's a simultaneous single step reaction. And then at the end, usually the leaving group, well, not at the end, but usually the leaving group is something that's already going to be stable with a negative charge. There are some times where, for example, if you have an alcohol, and you're wanting that to be your nucleophile, you might do a proton transfer reaction, some sort of base, for example, and make it into the alkoxide, and then that's going to be your nucleophile. But most of the time it's just the SN2, and we would think of this as more being like the setup for the reaction than anything else.